Hello, data lovers. It is Merdad. Welcome to my channel and another episode of Azure Data Fundamentals course, which we talk about Azure Data Services. So let's check it out. So, Microsoft Azure is a cloud platform that power the applications and IT infrastructures for organizations. And among that, Azure Data Services are there to support the transactional and analytical data workloads, and also providing the cloud solutions. When we talk about cloud-based services, they basically take form of three different types, which are infrastructure as a service, platform as a service, and software as a service. What are they? Let's check it out. So here I have a comparison of on-prem infrastructure as a service, uh, platform as a service, and software as a service. So when it comes to the software industry or computer-based solutions, we have some sort of components that you can find them in the on-premises column here that are including the networking, the the computers and how they are going to connect to each other, the storage, servers, visualization, OS, middlewares, runtime, data, and application. So when we are talking about the different levels of services in cloud, basically we are talking about how they are going to be managed and how they are going to be affect the cost in an organization. So when it is infrastructure as a service, uh, some of these components are going to be managed by that cloud provider. For example, here we have networking, storage, servers, and visualization are going to be managed by cloud and cloud provider, and the rest are going to be remain for the users and for the users of those services. Infrastructures as a service, was, for example, we can mention the virtual machines that we have in cloud. For platform as a service, whatever that we had in the previous one is applicable. Plus, OS, middleware, and runtime is also going to be managed by cloud. All you need to take care of is the data and application. An example for platform as a service, we can mention Azure Synapse Analytics service in Azure Data Services. And also, we've got the software as a service that everything is going to be managed by the cloud provider. Some examples there can be Microsoft Teams, Outlook, and the Microsoft 365 apps that we can just we may use every day. So the first Azure data service that I want to talk about is Azure SQL. So the Azure SQL actually is a generic name for a collection of data services that are based on Microsoft SQL Server, database engine that is going to include the Azure SQL databases. That is basically a standalone database in Azure environment, and it is going to be fully managed by basically by cloud provider, by Azure. We have the Azure SQL Managed Instance. It is basically a hosted instance of SQL Server and with some automation for the maintenance. And it has more admin responsibilities in comparison with the previous one. And we also have Azure SQL Virtual Machine, VM, that it is like, uh, infrastructure as a service, that a VM is going to be created for you, and you know, an instance of SQL Server is going to be installed there. And For Azure SQL, we have the roles that are going to be involved with them. We have database administrators. They provision and manage the Azure SQLs uh, to store the transactional data. Data engineers use them for getting the data, retrieving the data from Azure SQL databases for their ETL processes, load them for analytical purposes. And we also have data analysts. They may query the data to create the reports and their visualization. But for the relational databases, it doesn't finish for Azure SQL. We also have some services in Azure for relational databases, for the open source relational databases that they are basically the managed services for the open source database systems like uh, for MySQL, MariaDB, and PostgreSQL. MySQL is basically used in Linux, Apache, MySQL, and PHP apps. And for MariaDB, which is an improvement of the MySQL, and it is a compatible with Oracle DB. And the PostgreSQL is basically a hybrid database that is going to both work in relational data in the relational side of the things, and you can store the data in tables and also in custom data types. And the job roles and the roles in the industry, it will be similar as what we had in Azure SQL. We have Azure Cosmos DB, which is basically a global scale for non-relational database systems. And as general, we call them NoSQL. And it is not a there is no specific schema in the storing the data there. And we have it supports multiple APIs, such as for NoSQL, it supports PostgreSQL. We have MongoDB there, Cassandra, and also for tables. And basically, the data, as we have discussed before in the data format section, the data is going to be stored in JSON and also in the key value pairs or even column families and graphs. The same job roles applies here as well. However, software engineers, software developers may manage the data in Azure Cosmos DBs based on the requirements in their application. The next one, we have talked about the databases, both relational databases and non-relational databases. Now it is the time to talk about the files. When it comes to the Azure storage, we are basically talking about the files, and we can just store blob containers that it is in scalable one, very uh, cost effective, and for the binary files, for the big binary files. And there we can have file sharing, and also we can have the tables that are going to sit above blob storages. And the involved roles, basically, they can be used by data engineers. They use that as for example, destination or even sometimes source of the data for their ETL processes. And they can just load the data, for example, to the data lake N2, which is a uh, service that is sitting on top of the blob storage. We have a fantastic tool which is called Azure Data Factory, which is working with data, basically service to define and schedule the data pipelines to transfer and transform the data in ETL processes. Uh, Basically, the pipelines can be integrated with the other services. They can read the data from cloud data stores, and then it's gonna process that data, transform it to the acceptable format or values. Then it is going to just write it to another data source. And basically, data engineers are the most users of that, and they will build the ETL solutions to move the transactional data to analytical data storages. Uh, we have some sort of platforms for data analytics like Azure Synapse Analytics, which is basically a unified platform as a service, as I mentioned, for data analytics. It is including some components like pipelines. It is working somehow like and the Azure Data Factory. It is just for moving the data from transactional to Azure Synapse to do the actually the ETLs. We have the SQL database there. It is going to be used to store the data, but it is very optimized for data warehousing and where the read is very important and indexing is very important in analytical side of the things. And also we have the Apache Spark, which is an open source data processing system, and Azure Synapse Data Explorer that can be used for actually processing, the data and querying the data, which is related, to the timestamps. Actually, having the timestamp on that, like log files or even telemetry data by using KQL language. And the roles that are going to be involved with Azure Synapse Analytics are data engineers. They use it to create the data ingestions and for data warehousing and data lake storage. And also we have the data analysts. They explore the data and they integrate with machine learning and Power BI to model the data and visualize them. Actually, this section applies to both data analysts and data scientists. Another platform for analytical purposes is Azure Databricks, which is an actually Azure integrated system with famous Databricks platform, which is also including Apache Spark for processing the data using SQL, database semantics, and also an integrated management interface for large scale data analysis. And the roles that are going to be involved with that are the data engineers. They use data bricks and also Apache Spark to create the analytical data stores in Databricks, in Azure Databricks. And also data analysts, they create, the notebooks for analyzing, modeling the data, and visualizing them in order to be, presented to the high-ranking authorities in organization. We also have Azure HD Insight, which is basically also a platform for the analytical purposes, uh, which is providing the services for Azure hosted clusters in Hadoop, actually for Hadoop Big Data. And there we have some sort of technologies and components there, including Apache Spark for data processing. We have the Apache Hadoop, which has a MapReduce, some MapReduce jobs to do the processing for large volume of the data. And we have HBase for large scale NoSQL data storage and querying them. And also we've got Kafka, which is a message broker for data streaming processing. And we have also data engineers here to just use these skills to support the big data analytic workloads. Of course, data analysts and data scientists can make benefit of this service as well. The next one is Azure Stream Analytics. So when it comes to the real-time analysis, we can use this service that is going to basically, it is in 3 steps, right? It gets the data from streams, it is going to the input, it is going to then we process that by querying them, and then that analyzed data, or actually that processed data, is going to be stored somewhere, like data lake or whatever. And for analytical purposes, data engineers use that to just create those that process for the data ingestion for real-time analytical purposes. We also have Azure Data Explorer, which is similar to what we had in Azure Synapse Data Explorer. That basically analysts are going to work with this data to query the uh, those data that are related to the timestamps, like log file, and also the IoT telemetry data. We also have Microsoft Purview, which is basically used for the data governance in enterprise level. And it is going to actually create a map of data and track the data across multiple data sources and systems. Data engineers are here to use it to enforce the data governance across the enterprise, and also they make sure of the integrity of data which is used for analytical purposes. And the last data service in Microsoft that I want to talk about is Microsoft Fabric, which is a software as a service analytic platform, and which is basically an end-to-end analytics system that is based on open and governed lakehouse. There we have only one storage, and also we have some experiences there. It is basically bringing different experiences from whatever that we discussed so far as Azure Data Data Services, and it we picked some specific experiences from there, and all of them are included in this software, actually software as a service. And the experiences are data ingestion and ETLs, that is basically is done by Azure Data Factory and data flows in Power BI. We've got the data lake houses and warehouse analytics, that is bringing the data, actually bringing the feature of Azure Synapse. Uh, we have data science and machine learning, which is also using Synapse. And we have the real-time analytics, also Synapse. And we've got the data visualization, which is using Power BI. And for the data governance and management, it uses Microsoft Purview. And all of them are here to just make the life much easier for data analytical solutions. And of course, the all of these 3 roles, like data engineers, data analysts, and data scientists, are going to involve with Microsoft Fabric. Uh, Data engineers manage the data workloads, and data analysts, they analyze and actually visualize the data. And data scientists, they are going to model the data and prepare them to be meaningful for the system. Thank you for watching this video. I hope you enjoyed that. If you liked it, just give me a thumbs up. And if you haven't subscribed to my channel and you would like to have more videos like this, you can just subscribe and stay tuned for the next video of this series of Azure Data Fundamentals. We will talk about the fundamentals of relational data, and which is going to just talk about the normalization of the database and the relational data models. So until the next video, take care.